Okay. Very similar po to kinematics naman.
Mm-hmm.
Ito, yung ano pala po, yung mga weighing scale, di ba po dapat force yung inanala, yung measure, yung support force dapat po. How do they convert it into weight?
Ano yan eh, may spring. Alam natin yung response ng spring to forces.
So, kung yung spring po is very old, it will be inaccurate.
Depende sa spring. Siyempre, depende sa system kung ano yung gagamitin mo. Yung pinaka-primitive, yung isang primitive na method, di ba, yung may balance.
Opo, talaga ng known weights.
Hmm. Tapos may assumption doon na ano eh, na yung force due to gravity equal. Sorry, yung acceleration due to gravity equal. And pag-uusapan naman natin yung scales eh, how they work, ano yung ano niyan.
Is this situation theoretically possible ngayon po with the current technology? Three astronauts can get past and then they just push an asteroid? Or will they just be pushed back by the asteroid? I mean, there's no, is
Then,
there,
actually, ganito, pag ganyan, the di ba, when the astronauts push on the asteroid, the asteroid pushes back.
opo,
So bakit hindi no ba't hindi bumabalik yung so ano nangyayari diyan? Bakit even though the astronaut is being pushed back, ganito, tanggalin mo yung tatlo, isang astronaut lang.
bye.
So, anong mangyayari? Ano forces on so pag yung isang astronaut lang, yung nandiyan sa gitna, ano yung force on the asteroid?
Pag ganun po, tapos ang likot yung pag ganun.
Okay, so ang net force on the asteroid is how many newtons?
Mm, ano yan? 55 nito.
55 newtons. Ngayon, kung yung kung natutulak ng kung halimbawa moving together with the asteroid yung astronaut, ano forces acting on the astronaut? So ihiwalay mo yung ano yan eh, ihiwalay mo yung astronaut at saka yung object. Tapos pag-isipan mo ano yung forces. Tapos i-represent mo na sila as points. So astronaut, so yung ano muna, yung rock muna or yung asteroid. Ano yung forces acting on that? Kapag isang astronaut lang, yung the only force acting on the asteroid is
Pag ganun po.
force act gamitin mo yung labels na ano yung acting on the asteroid. Di ba meron tayong may force F something acting on something. Gamitin mo yung label. So, force from acting on the asteroid.
Malapit na.
So, astronaut acting on the asteroid, di ba? Okay, ngayon on the diagram on the separate diagram for the astronaut naman. Ano yung forces acting on the astronaut?
Forces acting on the astronaut.
Okay, so tapos ilang newtons yan?
Hmm. Alam mo?
Ngayon, kung halimbawa, astronaut 2 lang yung nag-act. Ano yan eh? So, Newton's third law says the force of the astronaut
Dapat equal.
dapat equal. Sige. So, bakit yung astronaut nag-accelerate to the right din? What exactly is happening? Ano yun, kasi kung yan lang yung force acting on the asteroid, dapat mag-accelerate backward yung asteroid. Yung astronaut.
Ano kaya? Di ako sa inertia?
Hindi.
Oo na, dapat kung may mas malaking inertia din, mas mahirap i-push. Okay.
Ganito. Ano ba yung suot-suot ng astronaut?
Jetpack. Okay. Meron siya
So,
forward.
ibig sabihin, aside from the force from the asteroid, the astronaut is being pushed forward by the jetpack.
So, kung wala po siyang jetpack, it's impossible to push the asteroid. Ganun po.
Hindi. Pwede, pero ang mangyayari, sige, what if ganito? Let's change the problem. So, pakisulat lang sa new page. Ito kasi medyo boring yan kasi add mo lang, divide by the mass of the astronaut, kuha mo yung acceleration. So let's change the problem to something na mas yung astronaut lang at saka yung astronaut not wearing a jetpack in space. So an astronaut with a mass of 60 kilograms. Kung isasama natin, ilagay natin 100 kilograms na lang. A 100 kilogram astronaut So, type mo na yung problem. Yun. Hindi, wag mo nang i-ano yan kasi ibang problem yun. Walang jetpack.
Jetpack. Okay.
So, wag mo nang i-illustrate kasi ang importante lang yung free body diagram eh. Select mo lang yan tapos delete. So, new page. And then type mo yung problem statement. Okay, ready na? So a 100 kilogram astronaut in space
Opo.
pushes a 300 kilogram rock to the right for 2 seconds. 2 seconds yung push na yan. Period. The force applied by the astronaut is 100 newtons. Okay, so assume that at the start, both astronaut and the rock are at the origin. And that they lose contact after 2 seconds. Yeah. Find the position versus time find of both astronaut and rock. Okay, so before we do that, ano yung forces? So represent the astronaut by a point. And on the right, represent the rock by a point. So hiwalay na diagrams yan. Kasi ayaw nating pagsamahin dahil magulo yung pag-illustrate ng forces. So, lagyan mo ng subscript ng label astronaut tapos sa ilalim. And more space. Kasi magdo-drawing pa tayo dyan eh. So, astronaut. Tapos, separate na dot somewhere on the right. So, hatiin mo yung page to the other half. Yan. Kasi nagdo-drawing tayo ngayon ng free body diagram. So, yung rock naman. So, label din. And then, on the astronaut and on the rock, ilagay mo yung vectors to represent the forces. And then, yung ganito, pag nagdo-drawing ka ng free body diagram, yung tail ng vector nandun sa position ng object. Tapos yung length ng vector, so may scale din yun eh. So yung length ng vector should correspond to the magnitude of the force. So if that's 100 newtons, tanda mo lang may scale yan. Ngayon, if ganito, ang sinabi, the astronaut is pushing the rock to the right. So ano yung force na nararamdaman ng rock? Label, tapos lagyan mo ng habaan mo pa yung arrow. Masyadong maliit siya. Habaan mo pa. It's going to be mas helpful na kita yung yan. At least kahit ganyan man lang. Tapos i-label mo. Force from astronaut. Teka, bakit merong ganito? Sa free body diagram, the only things on the diagram should be the forces experienced by the object.
Opo.
So, yan, yung force to the right, that's a force from what?
From the astronaut.
Label mo, F, astronaut. arrow, rock. Equals
Ano?
100 newtons. Ngayon, are there any other forces acting on the rock?
No?
No. Okay, ngayon, punta tayo sa astronaut. Ano naman yung nararamdaman na forces ng astronaut? So, what's acting on the astronaut?
Acting on pala. So, it doesn't, so hindi pala pwede lagay yung what is the astronaut acting onto
Mhm.
others.
Tapos, dapat, kasi kung ano man, ayan. So, hindi pwede yan, ano? So, rock acting on, which is, gaano kalaki? Equals
Newtons dapat.
100 newtons. Ngayon, sa free body diagram, dapat may scale yan eh. So, dapat, kung equal forces yan, dapat yung arrow lengths ng dalawa magkasing haba din. Na hindi kita from your diagram. So, habaan mo yung force acting on the astronaut para mag-match silang dalawa. Okay, so, ngayon, so kung ganyan kahaba yung astronaut acting on the rock, dapat ganyan din kahaba yung rock acting on the astronaut.
Wait. Ha. Funny prank. There.
Ayan. Okay, are there any other forces?
No?
No. Okay,
No.
so alam na natin yung forces acting on each.
Tamo.
So, ano yung accelerations ng astronaut at ng rock during the 2 seconds?
Okay. So, shouldn't, neither of them should move, technically. Equal force.
May
So,
net force acting on them eh. So ano yung net force acting on the astronaut?
if net 100 newtons.
So alam natin na F net is 100. Tapos ano yung sinasabi ng Newton's second law?
So, parang, ay, wala. So, yung
So
basically
from
ko,
Newton's second law, ano yung
parang,
acceleration ng astronaut?
tapos, but they will just separate. No actual work. Okay. So, So pupunta nga 'tong astronaut backwards tapos ni Rock will just go forwards.
Mhm. So, position versus time muna. So, ano muna yung acceleration ng astronaut?
Astronaut, astronaut nun.
Tapos remember, may sign, may signs dapat yan kasi
Wait na.
teka, I hat, di ba? Ngayon, so may minus. Or, ano yung accelerate? So, if you simplify that, magiging how many meters per second square? So, negative 1 meters per second square. So, yung acceleration ng astronaut is negative 1 meter per second square for 2 seconds. Pag nag-lose na sila ng contact, ano acceleration ng astronaut?
Okay. So, bumalik yung
So, for 2 seconds, yan, for the first 2 seconds, yun yung acceleration. Diba?
Opo.
So, to the left, negative 1. So, ano yung position versus time? Assume starting from rest pareho. So, pakidagdag yun. Assume both are starting from rest. Hindi, type mo na sa ano? Type mo na dun sa problem statement. So, ulong mo yung written work mo para ano, para may space. So, assume both start from rest at the origin. Okay, so ano yung initial velocity ng astronaut?
Negative 1 meters per second po.
Ne, acceleration yan. Yan yung second derivative ng position, di ba?
Opo.
So, ano yung initial velocity?
0.
0. Ngayon, alam natin initial velocity, alam natin acceleration, alam natin initial position. Ano ngayon yung x versus t para sa astronaut?
Mm, yan. Okay.
Wait. Ang acceleration ng astronaut ay d squared x dt square.
Pala. Okay.
Teka. Remember, hinahanap natin ay function of time.
Function of time. Zero.
Teka, 0, v sub 0 plus 80 yan, di ba?
Okay, so zero.
And then plug in mo yung values. 0 plus... Wait, function of time. Kasi gusto, pag nakuha, kailangan natin yun para mag-integrate tayo uli eh.
Ah.
Okay, so yung first derivative ng x with respect to t is negative t. So ano ngayon yung x versus t for the first 2 seconds? So gusto ko may function ako for x na valid between 0 and t. 0 and 2 seconds. So anong antiderivative? So x astronaut equals hindi ganito. Sige. Gawin natin yung methods ng additional math. Burahin mo muna yan.
Di ba po tama? Yes.
Kasi yung symbol natin, ba't GT?
GT, saan mo?
Yung V0 GT. Yung integral mo.
Tapos na, GG.
Hindi, ganito. Baba mo na, let's go to a new page. Derive natin yung kinematic equations. So, new page, para may, Okay, so, d squared x dt square. So, second derivative of x with respect to t square. Sulat mo muna yon, huwag ka magmadali. Sulat mo muna na d squared dt squared, d squared x dt square. Yung second derivative of x. Yan yung acceleration eh. d squared x dt square.
Kala ko po V.
Equals...
May nalito po ako eh. Kala ko po V and D.
Okay, so yung second derivative of x equals a sub 0 is equal to a, which is a constant. Ano antiderivative niyan?
V.
No. Yung pag in-integrate mo yan. Di ba, alam mo yung yung pag in-integrate mo yung a with respect to t, di ba meron kang something plus a constant?
So, may plus t.
So, dx dt equals so, derivative of x with respect to t equals, so if dx, so yan. Walang integral sign. Next line. So, dx dt, so, is equal to, So ang antiderivative ng A with respect to T is just no.
Hindi ba po? Ano yung
Ano
tama?
ba yung A is a constant? Kung ang A natin ay 3, ano yung dx dt?
VT, oh my gosh.
But V? A yung ano, di ba? Yung
A. So in terms of A po, wala pong V.
uh,
Hindi
so
ko
A
naiintindihan.
times hindi, merong in terms of A tapos may lalabas na T rin dyan kasi gusto natin yung time dependence. AT plus a constant. Pero kasi kumukuha tayo, nag-integrate tayo twice eh. So let's call that constant C1. Ngayon, integrate that again to get X. Teka, ano yung antiderivative ng C sub 1? Parang may nalaglag.
So, ano pong nangyayari dyan? Zero.
Pag in-integrate mo yung constant, magiging?
Wala. C2 na yun.
Hindi. Yung C sub 1.
Zero
Pag
po.
in-integrate mo yan.
C sub 1. Kaya pala.
Teka. So, C sub 1t plus C sub 2. Yan yung general solution ng second derivative of x with respect to t square equals a constant. Ngayon, check natin yung conditions natin. At t equal to 0, ano yung value ng a natin for the problem?
Pala. Meron ba?
Meron, negative 1. So a is equal to negative 1. Hindi, wag mo munang i-substitute. Sulat mo muna yung mga known.
Hindi mo po, known.
So given, so a is equal to negative 1 meter per second square. Ngayon, yung velocity at t equal to 0 is, so dx dt evaluated at t equals 0 is, wag mong idiretso dyan. Write a separate equation stating ano yung value ng derivative at t equal to 0. Ano mo yung may bar, tapos may subscript na t equals 0.
So yung
So
parang
dx
dito.
dt, so derivative evaluated at not x, it's t. T equals 0 is equal to, ano yan? Anong uli? Ano yung condition uli? Read the problem. No, t equals 0 yan. Yung initial condition natin ay at t equals 0.
Okay, so then yung ano po is 2 seconds.
Assume. Tingnan mo yung last sentence.
Both start from the, okay, the origin.
So ano yung derivative at t evaluated at t equal to 0? That's going to be equal to 0. Kasi we start from rest. Wag mong gamitin yung
So,
wag mong gamitin yung ano, ang ginagawa natin ay we're setting up yung values ng second derivative at yung value ng velocity at saka yung initial position at t equals 0.
What is causing confusion mo is this one? Yung A po is not labeled correctly. Yun.
Hindi, ganito. Yung A is a constant. And it's negative 1 meter per second square for this specific problem. Kaya ano yan eh. Kaya ganito. Sige, share ko yung notepad ko para makita mo yan. Kasi I think ano yan eh, para makita mo yung what it should look like. Eto. So, kaya kita ba yung screen ko?
Opo.
Okay, so ito ang problem natin ay it is known that the acceleration is equal, so the acceleration is constant. What we're doing here is we're looking for a general solution. So, pag in-integrate ko yung equation 1, I'm going to get a times t plus an arbitrary constant c sub 1. If I integrate this again, I'm going to get 1/2 a t square plus c sub 1 t plus another arbitrary constant c sub 2. So, sa problems na binibigay for constant acceleration problems, a is given. Tapos, usually, yung value ng derivative at t equals 0, that's also given. Yung x at t equals 0 is also part of the given. If you want to solve this, if you want to get yung expressions for x versus t. Ngayon, for the problem that we're looking at, this is negative 1 meter per second square. Ang dx dt or yung derivative ng position is velocity. Ano yung velocity when t equals 0?
When t equals 0, 0.
Okay, so ito. So this is 0 meters per second. Ngayon, ano yung position when t equals 0?
Position 0, 0, 0.
0 kasi
Origin ba?
nasa origin. 0 meters. So ito, so pag nagsosolve tayo ng ganitong klaseng problem, ito yung equation 1 is the differential equation. Yung nagiging problem sa Newtonian mechanics is i-set up yung differential equation. Sa ngayon, constant acceleration yung problems eh. Pero later, may mas weird na time and position dependence yan. So ito, usually, yung free body diagram is used to set up 1.
Opo.
So to set up a DE. And then yung problem natin ay i-solve it with and match the constants with ano yung values ng position at velocity at the start. So, since ito yung mga values, para mahanap natin yung C sub 1 at yung C sub 2, saka tayo magsa-substitute. Clear ba yung procedure?
Opo.
Kasi, ano to eh, general solution eh. Kasi what if iba yung given? What if ang binigay sa'yo ay the rock and the, kaya hindi ko binigay na ganun, paning at rest at saka nasa origin eh. Kasi what if ang binigay sa'yo yung rock at yung astronaut moving to the right with speed 3 meters per second? Eh, di magiging ganito yung initial condition. What if nag-start sila at somewhere else? Like, 10 meters away from the origin, nasa right, then it could be 10 meters to. So yung values ng C sub 1 at C sub 2 depends on, ang tawag dito sa part na to, these are known as initial conditions. The problem will tell you ano yung initial conditions, and then pag alam mo na yung initial conditions, you plug it into the general solution. Teka, malito. Sorry, this is X. Nag-integrate na tayo eh. Ayan. So, using this, we should be able to get, so for the problem that we're working on, 0, 0 for the astronaut. Ito. Tapos A is negative 1. Kaya ano yun eh, kaya pinapagawa ko sa'yo yung, set mo muna yung general solution, tapos separate and then write as a separate thing yung initial conditions. Kasi, iba-iba yung possible initial conditions eh. And then substitute to find the constants. So, for example, dito, A is negative 1. So, substitute in. So, ito. So, this is 4, 5, 6. So, if we go down here, alam natin na, so gagamitin natin yung condition na A is equal to negative 1. So, d squared x dt is equal to negative 1. So, this is going to be 7. And then, yung dx dt is negative t plus a constant. And then, gamitin natin yung condition kanina na 5. So, when t equals 0, x is 0. dx dt is 0. Kasi ito yung v eh. And then, plug in. 0 equals negative 0 plus c sub 1, which implies yung first constant, 0. And then, you can do the same thing. Nasaan yung object? So, x equals negative 1/2 t square plus c sub 1 is 0 times t plus c sub 2. And then, gamitin natin. When t equals 0, x equals 0. And then, substitute. To get c sub 2 is also 0. So, kapag alam na natin yan, then mako-conclude na natin na x is equal to negative 1/2 t square. V is equal to negative t. Kasi ito yung dx dt eh. And yung acceleration, alam naman natin is negative 1. These equations will only be true only for t equals 0 to t equals 2. Kasi pagkatapos ng 2 seconds, mawawalan sila ng contact. Okay, so ano yung speed ng astronaut when t equals 2? Ano yung v?
So when t equals 2, is equal to negative 2.
So negative 2 meters per second. So yan yung sa ano, yan yung sa astronaut. After 2 seconds. When t equals 3, ano yung v?
V is equal to negative 3. So patas ng patas po proportion.
Wait. Naghiwalay na yung astronaut at saka yung
okay. So nawala na yung
wala ng forces. Ano yung acceleration?
0 na yung acceleration.
0 na after 2, which means ano yung velocity after 2 seconds?
0. Ay, negative 2 pa rin.
Negative 2 pa rin.
Nothing is stopping in.
Oo. no forces, no change in velocity. So actually, for t greater than 2, v is still going to be negative 2 meters per second. Tapos kung gusto mong hanapin yung x versus t, x is equal to, when t is equal to 2, x is ano yun, negative 1/2 times 2 square, no? So it's going to be negative 2 meters. And then, when t is greater than 2, yung x magiging negative 2 meters minus, ano yung velocity? Negative 2 meters per second times t. Kasi constant velocity na yung astronaut. Okay. So, may similar na analysis para dun sa rock. So, kung yung rock naman, what can we get? So, stop sharing ko na muna to. So, set up something similar dito. So, ito, set this up for the rock. Ano yung initial conditions for the rock? Ano yung acceleration of the rock? Yun muna. Compute mo muna yung acceleration ng rock. Kasi kailangan mo yun para mas-set up yung initial conditions. Okay, so stop share ko na to, no?
Okay.
So gawin mo yung analysis for the rock. So at t equals 0, ang velocity ng rock ay 0. Kaya useful na separate mo yung general solution at saka yung initial conditions.
Doon ako nagkamali.
Teka, 100 newtons yung force of the astronaut on the rock. Ano mass ng rock?
300.
Okay, so yan yung acceleration ng rock, positive 1/3 meter per second square. And that's only going to be true for t between 0 and 2 seconds. So position versus so ano yung initial velocity ng rock? Tapos yung initial position, ano yan, kailangan i-state mo yung mga yan eh. Or x sub 0 ng rock is 0 din.
Ano po?
Okay, so ngayon, ano yung general solution nung nung differential equation natin? So the differential equation is d squared x dt squared equals a rock. And then, so,
Bro.
bakit may 2? Hinahanap
Mm,
natin ay functions.
ah, dapat dito.
So, yung position versus time ng rock ay 1/6 t squared. Yung velocity is 1/3 t. So, ngayon, after 2 seconds, nasaan yung rock?
Seven.
So, kasi yung equation natin valid only for t between 0 and 2 eh. So, 2/3 meters away. Ngayon, compare mo yan dun sa astronaut. Nasaan yung astronaut after 2 seconds? So, after 2 seconds, negative. Kung kasi pakita mo lahat ng steps, huwag mong i-mental. Kasi,
Ay, yung ano, yung nilagay ko ba sa
pag,
calculator?
I mean, isulat mo yung equation, yung substituting this and this. Kasi, pag binasa mo yan next time, magulo na eh. Tapos, wag kang mag-run through ng equation kasi yung previous equation is yung functional dependence ng R versus T. Yung next line mo is R evaluated at, di ba? Your symbols mean something. So dapat sa line na yan, okay, R evaluated at T equals 2. Ngayon, ano yung velocity ng astronaut at T equals 2?
Velocity. Hindi, negative 2 pa rin.
Yeah, so -2
Yun ba yung nakuha
meters
ka?
per second. Ngayon, ano yung velocity ng rock after 2 seconds?
Mm, ay, ito na.
So 2 times 2 is 4. 4 over 6. So 2/3 meters per second. Diba? So, so ito, kung yung rock ay 300 kilograms, yan yung velocities after mag-separate sila. Kung 2 seconds yung contact time. Ano yan eh. Pero kasi kung actual na situation yan, baka nga less than 2 seconds yung contact time nila eh. Pero nag-assume na ako na 2 seconds. Okay, ngayon, let's change the problem just so you can see anong effect ng mass. Same problem pero yung rock 1 ton. 1 metric ton. So 1,000
Like,
kilograms.
so like, yung the asteroid in question po, parang yun sa problem, that's pretty much 1 ton na rin po eh.
Mm-hmm. So 1 ton yung, ngayon, what if 1 ton? So same initial conditions, 2 seconds yung contact time, ano yung velocity ng astronaut? It's 1,000 kilograms. Ano yan eh, medyo safe yung assumption dito na walang gravitational force between the astronaut and the rock. Kasi ang liit ng gravitational force dito eh. So we will assume na walang gravitational force between the two. Pero actually meron. So ano kaya mangyayari? After 2 seconds, ano yung velocities nila? So same force, 100 newtons yung push.
Okay,
Okay.
so V pa rin is equal to
So pare-pareho lahat yan, di ba? Ng sagot after 2 seconds. Okay. Ngayon,
so wait. So it technically won't affect the astronaut at all. Parang no matter how big it is. Basta same yung force niya. He will be moved back the same amount of the same distance and same velocity, same acceleration.
pero yung ano naman, ano acceleration ng rock?
Mm, okay. So ngayon yung ano ng rock.
So after 2 seconds, ano yung velocity ng rock? Teka, bakit A? Di ba X yan? So, position ng rock is okay. So, after 2 seconds, 1/5 meters. 2 times 2 is 4. Okay. So, 4 over 20, 1 over 10, 1 over 5. Okay. Ngayon, so yan yung 1 ton yung mass ng rock. Paano kung 10,000 kilograms na yung rock?
1,000 kilograms. So, bigla lang ang meters per second. So, meters lang. So, kanina po gumalaw siya ng 2.32 meters. Ngayon, it's only 1/5 meter movement. Pero the astronaut still moves back 2 meters.
Mhm. So ito, after 2 seconds, so after 2 seconds, di ba, constant velocity na yung rock. So 1/5 meter per second pa rin after 2 seconds. Ngayon, what if ano naman? So ano yung, paano nagbabago yung results mo kapag 10,000 kilograms yung rock?
Mm, I think dito po yung makita ko rin po na pattern is yung V is equal to X. Okay. So, ano
So
siya?
kapag 10,000, after 2
siguro,
seconds, ano yung
ano ko po, 1/10 na. So, dapat over 200 na yan. So, 4 over 200. Okay, 50. Okay. So, by 10, it's increments dito na. In inverse proportional po siya. So, 150 meters na lang. So, 10 tons.
So, di ba, the bigger the rock, the less it's going to change velocity. Or, sorry, the more massive the rock pala, the less the change in velocity due to the force.
Pero kung let's say po yung ano yung so it doesn't really matter yung velocity po ng ano yes good. Pero yung let's say kung may rocket po, it should be as heavy as possible to really divert the course of the asteroid.
Kailangan malaki din yung forces. Kung gusto mo ng malaking changes in velocity. Which means, kasi, di ba, if you change the velocity, you can change the direction and the speed.
No po.
So, pag ganyan, the more massive the rock, the less yung magiging change ng velocity. Pero may change pa rin. Tapos ano yun pag lumaki pa lalo yung rock, nagiging significant yung gravity. Diba? Like, what if 1 billion kilograms yan? Hindi nagagana yung approximation dito na yung forces lang dito ay the pushing force from the astronaut and from the rock. May attractive force na rin due to gravity. Okay na?
Opo.
Kaya importante yung mga kaya importante dito yung free body diagram, yung setup ng differential equation.
Yung reason kaya nagka-misunderstanding pa yung mga mislabel na mga variables, etc. po.
Kaya kailangan rin i-rewrite mo to with better choices of variables. In particular, yung mga kailangan mong gawin dito ay be sure to distinguish between yung position of the astronaut and the position of the rock, the velocity of the astronaut, and velocity of the rock. Kasi dito, same symbol yung ginagamit mo eh. V at saka X lang eh. So, maglagay ka ng subscripts, XR, XA. Para pag kinompute mo, hindi nakakalito.
Bakit ano po yun? Subscript?
Ano yun? Sorry?
Subscript po?
Pwedeng maglagay ka ng subscript like, or pwedeng, yung iba ginagawa X1, kailangan may declaration kaya. At the start, let X1 or XA be
the start and then X1 yung parang at the, does it have to be in chronological order?
Hindi, yung ganito, yung subscripts kasi pwedeng may convention na pag 0 at t equals 0. Pero yung for other times, wala. I think ang dyan gumamit ka lang ng letter labels para na ma-distinguish yung objects. Like X sub A for position of the astronaut, X sub XR for the position of the rock.
Para hindi po sulat ng astronaut rock, parang baka cinematographer X something mga ganun po. Para maiksi lang.
Okay, so let's declare the variables para pag ni-rewrite mo. Kasi sayang yung oras mo kapag ngayon mo i-rewrite eh. Gusto ko makita lang yung rewrite next time. So, yung choice of variables ganito. So type na lang, let X subscript A be the position of the astronaut.
So, is it a fallacy nga po na yung, what do you call that? Fallacy na yung parang R is the position. Kasi I mean, isn't that the displacement? Are they interchangeable?
Hindi. Yung displacement is change in position eh. Yun yung technical definition niya. Pero kasi magulo yung paggamit minsan ng ibang books eh. Na gagamit nila yung displacement when they mean position kasi ang reason nila, yung position kasi is a displacement from the origin. I think it's better to just use position vector for position. Tapos, yung displacement, reserve it for changes in position. Kaya lang, yun nga, hindi universal yun eh. So, position of astronaut, position of rock. Tapos, V sub A, ganun din. So, pag may subscripts, yun. Tapos, A sub A, yung acceleration ng astronaut. Tapos, A sub R, yung acceleration ng rock. Okay? So, they write explaining everything as you go through na ito yung differential equation, ito yung position, yung velocity versus time, ito yung position versus time, and then, if i-fit mo yung conditions dun sa constants. Okay. Yung modification ng problem na to ay, what if both astronaut and rock are moving at a speed of 10 meters per second to the right bago i-push ng astronaut. Yung yeah. So type mo na lang. What if the astronaut and the rock at equal to 0 are moving at or are moving together at 10 meters per second to the right. Tapos saka lang magde-decide yung astronaut, and then after t equals 0, dun magsisimulang i-push ng astronaut yung between t equals 0 and t equals 2, the astronaut pushes the rock forward
To the right po or forward?
to the right. Pwede yung forward. Okay, pushes the rock forward or to the right with a force of 100 newtons. So same force